Echo.
Hey Brainiacs! Ready to turn confusion into aha moments? In this video, we'll finally clear up the difference between valency and atomicity. At school, you may have heard, valency equals combining capacity of an element. Atomicity equals number of atoms in one molecule of an element. Sounds simple, but what's the real difference? Let's start from scratch. Take sulfur. It has 6 electrons in its outermost shell. To complete its octet, it needs 2 more. So in basic terms, we say the valency of sulfur is 2. But here's the twist. Sulfur doesn't stop there. In higher classes, you'll learn that stability isn't just about filling the octet. It's about energy. Atoms bond in ways that make them more stable, meaning lower energy. That's why sulfur can sometimes expand its octet and show valency 4 or even 6. Cool, right? Now, what about atomicity? That's simply the number of atoms of an element that naturally stick together in a molecule. Sulfur in nature exists as a crown-shaped S8 molecule. That's 8 sulfur atoms linked in a ring. So the atomicity of sulfur equals 8. See how valency and atomicity are totally different? One is about bonds, the other about how atoms group together. Let's zoom in for a clearer picture. Think of atoms like kids holding hands. Valency equals how many hands each kid can use. Atomicity equals how many kids are in the group. Some kids walk alone, helium is a lone wolf. Some always pair up. Hydrogen and oxygen love the buddy system. Some move in big squads. Sulfur hangs out in an 8-member gang. Now, let's test this. Take oxygen. The whole compound doesn't have a valency, but each atom does. Each oxygen atom makes 2 bonds, so valency equals 2. In nature, oxygen exists as O2, so atomicity equals 2. It's the same when the question is regarding oxygen or oxygen molecule or oxygen element. So valency equals bonds per atom. Atomicity equals number of atoms in the molecule. What if we look at a compound like CO2? The whole compound doesn't have a valency, but each atom does. Carbon forms 1, 2, 3, 4, counting 4 bonds, so valency equals 4. Each oxygen forms 2 bonds, so valency equals 2. And remember, atomicity only applies to elements in their natural form, not to compounds. Now, here's where students often get spooked. Sulfate, phosphate, nitrite, chloride, cyanide, perchlorate, ammonium, permanganate. What are these compounds? They are radicals. A radical is simply a group of atoms that acts as a single unit and carries a charge. Let's take an example, chloride. To find the valency of a radical, just look at the charge. -1. Take the absolute value of the charge, and that's your valency. The valency of chloride ion is 1. Next, phosphate. Charge is -3. Take the absolute value of the charge, and that's your valency. Valency equals 3. So what do these 2 terms really tell us? Valency equals how many bonds an atom or radical can form to become stable. It helps us write chemical formulas. Atomicity equals how many atoms of an element naturally stick together. It helps us write molecular formulas of elements. We need both valency and atomicity because they answer completely different questions in chemistry. Think of it like sports, similar to how a particular team in a game always has a fixed number of players. An element has fixed atomicity, but the scoreboard has different scores for the team when it plays with different teams, just like how valency. So just like how in sports, you need both a score, valency, and number of players on a team, atomicity, in chemistry, you need both terms to understand the full picture. We cannot throw away one and keep the other. Both are equally important. That's it, folks. From zero glow to full disco, another confusing concept cracked. If this video turned your head scratching into disco bulb moments, like, comment, share, subscribe. And if you've got more confusing chemistry terms you want me to break down, drop them below. I'd love to help. Until next time, keep questioning, keep learning, and let your neurons party on.